My name is Azim Baig and you are watching AZ Tech English. Today we discussed about tungsten halogen lamps. In 1958, Elmer Friedrich and Emmett H. Wiley has developed tungsten halogen lamp by introducing a halogen gas, basically iodine, inside the incandescent lamp. A halogen lamp is a type of incandescent lamp. The conventional incandescent lamp contains a tungsten filament sealed within a glass envelope that is either evacuated or filled with an inert gas or a mixture of these gases, typically nitrogen, argon and krypton. When electrical power is applied to the filament, it becomes hot enough, generally over 3,600 degrees Fahrenheit, 2,000 degrees Celsius, to become incandescent. In other words, the filament glows and emits light. During operation, the tungsten evaporating from the hot filament condenses on the cooler inside bulb wall, causing the bulb to blacken. This blackening process continuously reduces the light output over the life of the lamp. A halogen lamp comes with a few modifications to eliminate this blackening problem. The bulb, made of fused quartz instead of soda lime glass, is filled with the same inert gases as incandescent lamps mixed with small amounts of a halogen gas, usually less than 1% bromine. The halogen chemically reacts with the tungsten deposit to produce tungsten halides. When the tungsten halide reaches the filament, the intense heat of the filament causes the halide to break down, releasing tungsten back to the filament. This process, known as the tungsten halogen cycle, maintains a constant light output over the life of the lamp. Basically, without halogen gas, incandescent lamp filament gradually loses its performance because of its filament evaporation at higher temperature of operation. The evaporated tungsten from the filament of normal incandescent lamp gets deposited inside the bulb surface gradually. Thus lumens get obstructed from its way to come out from the bulb. So the efficacy lumen, watt of the incandescent lamp goes down gradually. But the insertion of halogen gas into the incandescent lamp overcomes this difficulty in addition to different advantages. Because this inserted halogen gas helps the evaporated tungsten to form tungsten halide which never gets deposited on the inner bulb surface at bulb surface temperature between 500 K and 1500 K, so the lumens never face obstruction. So lumen per watt of the lamp does not deteriorate. Again, due to insertion of pressurized halogen gas, the rate of evaporation of the filament goes down. Working principle of halogen lamp. In incandescent lamp, due to high temperature, tungsten filament gets evaporated during its operation. Due to convectional flow of gas inside the bulb, the evaporated tungsten is transported away from the filament. The wall of the bulb is relatively cool. Hence the evaporated tungsten then is adhered to the inner bulb wall. This is not the case when halogen like iodine is used in the bulb container. The temperature of the filament of the halogen lamp is maintained at about 3300 K, hence here also tungsten will be evaporated from lamp filament. Due to convectional flow of gas inside the bulb, the evaporated tungsten atoms are transported away from the filament to relatively lower temperature zone where they combine with the iodine vapor and form the tungsten iodide. The temperature required for combination of tungsten and iodine is 2000 K. Then the same convectional flow of gas inside the bulb carries the tungsten iodide to the wall of relatively lower temperature. But the bulb is so designed that the temperature of the glass wall remains between 500 K and 1500 K, and at that temperature tungsten iodide does not adhere to the bulb wall. It goes back towards the filament due to same convectional flow of gas inside the bulb. Again, at the close vicinity of the filament where temperature is more than 2800 K, the tungsten iodide gets broken into the tungsten and iodine vapor. Because this is the required temperature for breaking tungsten iodide into tungsten and iodine atoms is more than 2800 K, then these tungsten atoms further proceed and get redeposited on the filament to compensate previously vaporized tungsten. After that they again get evaporated due to high filament temperature and become free to acquire iodine to form iodide. This cycle repeats again and again. Hence the filament does not get evaporated permanently, so temperature of the filament can be maintained at very high level compared to normal incandescent lamp, which makes it more efficient, i.e. more lumen, watt rating. As there is no permanent evaporation of filament, the lifespan of the tungsten halogen lamps gets much longer with clarity of illumination. The chemical equation is construction of halogen lamp. Comparing to the halogen lamp, the incandescent lamp is able to provide only 80% of its lumens at the end of the life as the clarity of glass wall becomes fade due to tungsten deposition on it, whereas the tungsten halogen lamp is able to provide above 95% of its lumens at the end of life. Previously, borosilicate or aluminosilicate glass was used to make bulb of the halogen lamp. Because they have higher temperature withstanding capability and their thermal expansion coefficient is very low. But nowadays quartz is widely used to make halogen bulb glass. Quartz is transparent silica and pure silicon dioxide. It is very stronger and it withstands higher temperature as compared to the borosilicate or aluminosilicate glass. Quartz bulb can be soft material above 101,009 K. Again, around the filament 2000 and K 800 K must be maintained to get continuous halogen cycle. So the distance between the filament and quartz bulb wall must be maintained in such a way that the quartz bulb wall gets temperature below 1900 K. The bulb wall should be stronger and smaller in volume such that the lamp can be operated at the inner pressure of several atmospheres. Again, higher pressure inside the bulb reduces the rate of evaporation of the tungsten filament. A certain amount of nitrogen and argon are mixed in addition to the halogen gas inside the bulb to maintain this higher gas pressure inside. Thus the lamp can be operated at the higher temperature and with higher luminous efficacy for long time. Most of the lamps in present days are with bromine instead of iodine. Bromine is colorless whereas the iodine is purplish tint. Application of tungsten halogen lamps. Tungsten halogen lamps can have a number of shapes, but they are most often tubular with the filament oriented axially. Again, they are available in both double-ended and single-ended types.